Hey guys, today I'm going to be giving a little bit more of a walkthrough and demonstration and speaking more on a matter of principles as opposed to a technical walkthrough. I'm going to be showing the pros of why you would want to use time-based logic over step-based logic, and I think that can best be demonstrated through just a literal example. So here we have two squares that are moving at the exact same speed for now. So we have an FPS of 60 frames per second. And that converted, I did the math already, took care of all of that stuff. That converted into either 72 pixels per second or 1.2 pixels per frame, assuming that we set off at the initial speed of 1.2 pixels per frame. That's like an H speed, the H speed keyword. So let's say you're playing your game and your FPS dips. So you can scroll down to change that. So if you see here, if you ever get like a stutter in your game, the time-based movement actually continues at the exact same speed you want. As a matter of fact, if we stop and shake the game like so, and the game technically pauses, and then we let go, that square actually finished the loop and kept going. See, we sit here, we jiggle a tad, and we let go, and actually kept moving. Meanwhile, the step square paused entirely when the game did, and it relies entirely on the actual frame rate. So if I scroll up, bring it back up to 60 frames, not only does it actually take a second for the real frame rate to catch up, which dives back down every now and then entirely out of our control. But let's say they're roughly now moving the same speed. So let's say one day you realize you want to run your game at 120 FPS or 140 FPS. So we tune that up. Let's go all the way up to 140. So now this is moving super fast. It's moving way faster than the time-based one, right? So now you've actually affected the player's experience. Everything is moving over 2 times faster. So now you have to go everywhere in your code and hunt down everything that's frame-based and adjust that accordingly. And then let's say you want to change the frame rate later on. This is horrible. So the time-based stuff, it's always consistent. You always consistently get exactly what you want, regardless of the frame rate. This can be used for movement, like so. It can also be used even for animations. Let's say you double the frames of an animation and you double the frame rate of your game, but then you still want the animation to take place over the same amount of time so that it doesn't affect the player experience. It actually just makes the animation visually look even smoother. See, that would be an instance where you would want to use a time-based animation. So there's a bit more computations that go into this, but I swear it's absolutely worth it. It's a little bit more of an advanced topic. You can download this project file. I always include the source code with everything I'm demonstrating if you want to take a look at a bit of the math that's going on behind the scenes and try to implement it into your own project. As a matter of fact, it looks like I could maybe spin a game off of this, some sort of time-based game of racing, or maybe there's some pickups and it affects the frame rate of the game. That could be an interesting little concept because this looks like a little bit of a track racer. Okay, so I hope that clarifies a little bit on why you would want to use time. It's objectively better. It is a little more complicated, so you might not always need to use it, but for bigger projects where you need things to be exactly the way you want, things to be happening exactly how and when and why, all on a matter of time, that's when you would want to use that. Okay, I appreciate it. Thank you for watching, and I'll see you next time. Bye-bye.